important few notes that I want to talk about. So all stuff, Tom, that we've seen before, but all stuff that is important because it might pop up in the test tomorrow. The first one is just a recap from chapter 1. If we have ln of a function, it exists provided the function is positive. And notice here, it's not greater than or equal to, it's just greater than. Okay, so if we wanted to know the domain or the values for which the function exists, we would go, well, it exists when 2x take 1 is positive, greater than 0, and then just solve that inequality. Okay, the second point, again, talking about like when a function exists, what's its domain. This function here, the square root of sine x, will exist if sine x is positive. Okay, so if we were to look at our unit circle, we would go, oh, sine x is positive between here and here, isn't it? That's where we've got positive y values. So we would say it exists between 0 and 2 pi. Now notice here, notice the difference. Here I'm including the point because you can have the square root of 0. The square root of 0 is just 0. So I've included the boundaries of the domain there. Sorry, that shouldn't be 2 pi, that should be pi. Between 0 and pi. Whereas up here, we're not including the point because ln of 0 does not exist. Okay? Now, just on this, all right, this is only one solution of it. Okay? And like with all trigonometry, there's an infinite number of solutions. So I'm going to take you back to year 11 when it says something like find all solutions for sine x is half. Okay, this is where we introduce you to this kind of thought. So if you were to look on the unit circle again and you go, oh, sine is half, that's going to be there and there, you'll get x is pi on 6 and 5 pi on 6. All right, and that would be correct with a restricted domain. That would be correct between 0 and 2 pi. But if it says find all solutions, that means it wants to know all of the solutions when you keep going around the unit circle that way and when you keep going back around that way. Okay, because if you think, what is sine x but a wave that keeps going up and down? So for these solutions, the way we communicate that there's more, and it's really simple. The way we communicate that there's more is we would say x is pi on 6 or 5 pi on 6 plus k2 pi, where k is an integer. Okay, so that's how we write it mathematically. K e z, that's a z, plus k2 pi, where k is an integer, is another way to write it. And let me explain what that means. If we want to go from this point, if we go around, okay, we've moved around 2 pi, okay? So that would be when k is 1. If we go around again, we've gone around 4 pi. That would correspond with k being 2. And so this step, okay, this part here, it allows you to solve for every solution. All right, now I'll bring this up. We learned it in year 11. It was in the exam last year. Okay, and I marked the second booklet of the exam. People had to, there was 4 marks to a question, and lots of people didn't get this last mark because they didn't include all solutions. They only included the first 2 solutions. Okay, so we've got to be careful. Is it looking for all of the solutions or just one of them? Okay, so all that is in the context of this one here. We've got the square root of sine x is going to exist if sine x is positive. Well, it's positive over this region plus k2 pi. It's going to be positive for every 2 pi of this region. Okay, so we need to put there plus k2 pi where k is an integer. Okay, so I've explained what it means. All right, it's not necessary to know what it means. Okay, you're just getting a mark for writing that there. All right, so that's when that function is going to exist because we can't have the square root of the negative, can we? Okay, so that's why it has to be positive. All right, so they're the 2 sort of main ones. The rest one's just sort of stuff we've already talked about. Firstly, if we have a rational function, that's one function divided by another. The roots, we use these words interchangeably. The roots, the zeros, the x-intercepts, they occur when the numerator is 0. When the top is 0. And it's going to be undefined, or there will be an asymptote when the denominator is 0. Okay, that's nothing outrageous. Simplify. Okay, so I'm going to log on to Vivi in a moment and scroll through a test and show you guys. It says very clearly in the very first question, don't simplify. Okay, the only time you're required to simplify is if it says show that the derivatives is this. Okay, and then you have to manipulate it and re-rank it until you get it's equal. The other thing about that is if you do simplify, you won't be penalised. Okay, so feel free to. All right, it just says you don't need to worry about doing it. All right. Okay, just a couple of ways we should think about these things. Okay, sine of x on 2, that's sine of half x, sine of kx. Okay, that's how we should be starting to think about that. If we have a function on top of a number, all right, we should not use the quotient rule here. You could use the quotient rule, and you would get the right answer in order to differentiate it. It's just a long way of doing it. All right, what we've got is a function on a number. We can just bring that number out the front. We've got 1 on 7, and then you just need to differentiate everything inside the bracket, term by term, simple differentiation. Okay, whenever we're confronted with a log, okay, let's look. Can I use one of the logarithm laws? Okay, that's the first question. Can I simplify it and then differentiate it? That's going to make it a lot easier. Notation. Okay, if we have y, all right, then we should maintain the same notation. We should write dy on dx. Okay, if we have f of x, all right, then we'll have f dash of x. And I want us to be very clear, okay, I've seen some people in the past where it says something like differentiate, differentiate the square root of x squared plus 2. They'll do something like this. They'll go, equals x squared plus 2 to the half equals half x squared plus 2 to the minus half times 2x. Okay, so the calculus is correct. The notation is terrible, okay? We need to have y, dy on dx. We're very clear when we've performed the differentiation. Because this function and this function are not equal. We have differentiated that, and that's what we come up with. That's why that's the derivative. Okay? Seems obvious. If you've been doing some of the practice tests, you will notice there are sometimes some quadratics that you need to factorise. Okay, so you do, like that's just assumed knowledge. The fact that you know how to factorise a quadratic, you know how to use the cross method. Someone in the other class said, can you put the quadratic formula on the sheet? Okay, because so if you can't factorise it, you can resort to quadratic formula and you still will get the right solution. So I will put quadratic formula on the formula sheet as well. Okay, so that's going to be on there. All right, if you don't know what to do, let's say you get to a problem. All right, you read it and you've got no idea, just differentiate. Okay? Every question requires you to differentiate. Okay, so if you don't know what to do, you can still get marks. Like as a marker, I'm looking, I want you guys to win, I want you to be successful, so I'm looking for where you've got marks. I'm not looking for where I can take marks off. Ooh, where can I take marks from? No, you start with full marks, all right? And you start with 0 marks and I'm looking, how can I give you lots more marks? That's what I want to do, okay? So that being said, it's better to write something than nothing, okay? You don't get penalised for writing nothing. You don't get penalised as in marks taken off for writing the wrong thing, all right? If it's wrong, you just get nothing. But if it's right or if you've done something a little bit right, then you can still get marks. So get as many marks as you can. Okay, when we're confronted with A, B, C, K, all right, don't be alarmed. They're just numbers and just treat them as numbers. And then the last one where it says horizontal slope. Horizontal slope occurs when the derivative is 0. Okay? So I'm just going to bring up the 2021 test, so last year's. So give me a couple of seconds while. So here we are on question 7. I'm going to just be flicking back and forth a bit. Okay, so here we are on question 7 of the 2021 test. All right, it says, using first principles. That means you have to use first principles, okay? Show that the derivative is this, okay? So that means you do have to perform some simplification process, and your final answer should look like that. All right, if I scroll back up to question 1, it says, differentiate without simplifying, okay? So that means you can just differentiate. If you do simplify, so like let's talk about that first one. We've got 3x to the power of 5. Okay, so when you differentiate that, you could write it as 5 times 3x to the 4. All right, full marks. I'm just talking about this term, not the whole thing. Or you could write 15x to the 4. Full marks, doesn't matter. Okay, like it's easier to do that. Okay, so in the circumstance where it is, feel free. Anyway, said enough about that. Let's scroll through. First principles. All right, so here, it doesn't say you need to simplify, so you don't need to. All right. Same with this one. It just says find the second derivative. That's all you need to do. All right. Only if it says show that the derivative is this, do you need to simplify. All right. What about this one? When you're confronted with something like this, we want to get as many marks as we can. Okay. That means we need to use the information. All right. So you can get 3 marks here. All right. I think it's worth 5 marks. You can get 3 marks here without doing any complex algebra, okay? You get 3 marks here from, firstly, doing the derivative, okay? So if you just differentiate that, as long as you do it properly, okay? But if you just differentiate that, you get 1 mark, okay? You get the second mark for using the first piece of information. We've got when x is 1, the y value is 9. So even if you just make that statement, you get a mark. You're recognizing I need to use this piece of information and I need to put it into the function. And then the same with the third mark. You're getting the third mark for using the second piece of information. All right? When x is 1, the slope is 4, putting it into the derivative. Okay, so you can get 3 marks there, like pretty easy marks, and then the last 2 come from that sort of complex rearranging and synthesizing of those 2 simultaneous equations. All right, what about this one? Given that y is this function, find the exact value of x such that the slope is 9. Okay, so it means find the derivative, all right, differentiate, we always do that, and then find x such that the derivative function equals 9. Okay, so some algebra there. I didn't talk about this one yet. Okay, so if you've been doing the test, and I might stop there with the job. If you've been doing the practice test, you would have seen this one pop up. And they appear a bit later in the second derivatives exercise as well. So we have y equals e to the x, the square root of it. All right, and it says, show that the second derivative is equal to 1/4 of y. All right, now there's a temptation here to write that this is e to the x to the half, okay? But that's not true, all right? What that is that's e to the square root of x. Whereas here, we have the square root of e to the x. All right, notice the difference between them? Okay, so that means when we write this with index laws, this is going to be e to the x half. Okay? And then we're just using that index law. If we have a to the m to the n, it's a to the m times n. So this simplifies to e to the half x. All right, so y. And now we're ready to differentiate. dy on dx, half e to the half x. Second derivative is going to be, that half will stay there, half e to the half x. That's 1/4 e to the half x. Right? It says show that the second derivative is 1/4 of y. Well, this is y here, isn't it? So if we put that there, we've got 1/4 of y. Alright? So maybe some of you don't already. Okay, out of what I've spoken about up here, is there anything anyone wants to ask? No, it's going to be lots of fun. It's a good test, I'm pretty happy with it. So, yeah. No.
Do you have those tests?
Yes, I've got them all here, so thanks to those that liked the post.